What's up, calculus students? Sorry I couldn't be there during class, but you're going to be fine. You have a test Wednesday. Uh, these are the practice problems we're going to do before our quiz today. So you're going to probably pause the video, do the practice problem, then watch me explain it, then go to the next problem. Okay? Quiz you need to be done by the end of class. I'm going to have the submission set up so that you can't submit the quiz until get into the quiz until like 30 minutes before class is done, or like 35 minutes. And then that way you have the 35 minutes at the end of class to do it. Okay, so be ready for that. The quiz is not going to be like whenever you want to do it. You have a window towards the second half of class to do it. Different types of questions you're going to see on your quiz today. One, all getting you ready for your test on Wednesday. Your test on Wednesday, people have not been doing well on it. You need to practice. You need to prepare yourself for your quiz, for your test on Wednesday. You got the AP classroom. You have your quizzes that will be published for you to redo. Okay, make sure you understand how to do every single problem. First question will be like a fill in the blank. So here's a fill in the blank type question. You have a differential equation. You have an initial condition. You're asked to find the value at 1/2. Okay, so we know to separate our variables using algebra. And then we're ready to take the antiderivative of both sides. Now, the left side, I'll talk about in a second. The right side, easy, x squared plus c. To do the left side, make sure you understand that, yes, you would rewrite it as like a negative power, but you're not going to use a logarithm to take the antiderivative of e to the negative y. This is like an undoing of the chain rule. The antiderivative of e to a power is e to the power, and then undo the chain rule. So this ends up being negative e to the negative y. How do you know that? Like, think about the derivative. Take the derivative of this. Take the derivative of your antiderivatives. You should get what you have in the integral. Like, if I took the derivative of this, I'm going to get e to the negative y. All right. The next steps involve solving for y, and then finding c, and then finding what we get if I plug in 1/2. I'm going to isolate the e to the negative y by taking the opposite of both sides. This c is different from this c. If you want to note that they're different, make this c1, c2, because I took the opposite of c1 to get c2. I'm going to take the natural log of both sides. When I take the natural log of the right side, make sure the entire side goes in the natural log. But I still have negative y equals the natural log of negative x squared plus c. This is c2. And then I can finish off by taking the opposite of both sides, but that just goes outside the logarithm. Okay, so this is the start. This is our general solution. I have the initial condition y of 1 equals to negative log 4. Where some students might make errors is dealing with this negative x squared. Make sure you know order of operations, square the number first, then make it negative. So if I plug in 1, it's 1 squared times the negative 1 makes it negative 1 plus c, not positive 1. A lot of people think, oh, negative 1 squared is positive 1. Not the case. You see negative natural logs on both sides. You can take the opposite of both sides, e to a power both sides, or you just recognize that, oh, the inside must equal each other. You get c is equal to 5. So this is your particular solution, negative log negative x squared plus 5. I ask you to find a specific value. You will type in this value into your calculator. And you will provide your answer, rounded or truncated to the third decimal place. Negative log 4.75. Okay, negative 1.558 would be the answer that you would do plug into your fill in the blank spot. Okay, the next type of question you're going to see is something like this. Okay, now what I do is not ask you to solve, but look at the way I've solved it. There's 2 ways to do it. Either which one is the correct way to solve it. For those questions, I advise you actually do the problem, get the answer, and really just look at the answers. Make sure the answer that you got is the same as the answer that one of the worked out problems got. If you don't see your right answer, maybe then look into my work and my details. That's one different type of problem. The other different type of problem is find the mistakes. Like, where is the first mistake made? Okay. I'm going to do this problem with two mistakes, and I'm going to see if you can figure out where the two mistakes are. Okay. So here we go. I'm going to do the problem right now. Not going to say anything, and see if you guys at home, while you're watching this video, can find the mistakes. Okay. There, I did it. Looks right, right? No, you should find two mistakes here. The first one comes here. The antiderivative of 3y minus 2 to the negative first is natural log of 3y minus 2, but times a third. So there's my first mistake made, is I need that 1/3. That means if I were to solve, I would get rid, and this would become a 3x squared after this disappears. Okay. The next step is I would take e to the power to both sides, but when I take e to the power of the right side, this plus c does not end up as a plus c afterwards. It ends up, and this is a 3x squared now, as a plus c up here. Okay, and then we talked about the multiple steps you can do to rewrite this so that it's easier to find. This becomes e to the 3x squared times e to the c, using the exponent property we talked about last class. So this is c e to the 3x squared. So if I were to write the correct solution, general solution, it'd be c e to the 3x squared plus 2 divided by 3. Okay? So that is that. In the problem, it's like step 0, step 1, step 2, step 3, step 4, step 5. Which step did I make the error? Find the first one, the first error where it's like, oh, from step 2 to step 3. Step 3 is where I see the error. You'd say step 3 is the first error. Okay. Other types of questions like that. Okay. Find the correct solution, or where are the mistakes, or let's do a couple more where you're just solving and finding the value. This is a fill in the blank. You should pause, obviously, try to do this one. Here we go. I separated my variables. This right side I like putting because I think a lot of people make the right side harder than they need to make it. The antiderivative of the left side, log absolute y. Antiderivative of the right side, some people think they need to undo the chain rule and like write this as stuff to the second power times 1/2 and then do another. It's going to make things more complicated than you need to be. Because this is just a first power, it's not any other power, just get rid of these. Pretend like they're not there. And then you're realizing, oh, I just need to take the antiderivative of 3 and the antiderivative of negative 2x out of plus c. E to the power of both sides, I get absolute y equals e to the 3x minus x squared plus c. I'm going to leave the x's up where they are, but I'm going to move that c down using that exponent property we talked about. So it's e to the c, e to the 3x minus x squared, and that's c e. The y can be kind of, the absolute can kind of be ignored so long as you're finding what the c value is. So don't worry about the absolute value if you're going to go ahead and find c. I have the initial condition 0, 4. So I plug in 4 for y and 0 for x. I get c is easily 4 if I've moved that c down, giving me my general solution, or my particular solution, y equals 4e to the 3x minus x squared. And then I plug in 1. 4e squared. plug that into your calculator and get the decimal, type that into the fill in the blank. 3 decimal places rounded or truncated. There might be a question on your quiz, depending on which form you have, where I don't say round or truncate, but it is a decimal, or I do say round or truncate, but the answer is a whole number. Just don't freak out. Just get the answer, and if it's a whole number, type in the whole number. If it's a decimal, type in the decimal. Rounded or truncated 3 decimal places. Some people are getting confused about like the directions and like, hey, Mr. Messer, I didn't get a decimal, but you say round or truncate to the 3rd decimal place. It's okay. It's okay. All right, I'm gonna do one more, and this is a good one. Another one. It's like, how do I solve this? What I advise, though you can do it differently, but it might get confusing. Leave. If you don't see any X's, or if you even do, leave the constant over there on the right side. Unless there's like addition or anything, leave the constant, just move the Y. That works out very nicely because the antiderivative of -3 is -3x. You don't have to worry about multiplying by a 1/3 on the left side. You don't have to worry about like factoring that out, anything like that. Don't forget your plus c, e to the power of both sides. Ignore the absolute value. Y of 0 is 6. 6 equals c e to the 0. C is 6. Y of 1, 6 e to the -3rd. Type that in your calculator. Okay, last one, and then set you free. I like this one because you got multiple things. You got x's and y's in parentheses. I'm going to switch this from y minus 1 to 1 minus y, just so we're careful. Okay? Don't distribute, obviously. You're just going to divide the 1 minus y. And you're going to multiply by dx. You should be trying this by yourself right now. You take the antiderivative of both sides. Now, again, the right side's antiderivative, since it's a first power, just take the antiderivative of each of the pieces. Antiderivative of 1 is x. Antiderivative of 2 over x squared, I'd rewrite it as 2x to the -2nd. Add 1, multiply by the reciprocal. This becomes x to the -1st times -1. But that -2 in this negative becomes a +2, so it ends up being 2 over x. The antiderivative of the left side, well, let's be careful. You would rewrite this as 1 minus y to the -1st. The antiderivative of a -1st power is the natural log. But you have to undo the chain rule here because we have a coefficient of y. Y's got a -1st. If I took the derivative of this, I would not just get 1 over 1 minus y. I'd get 1 over 1 minus y times -1. So that's why I need a negative there. Okay. It asks you to find the particular solution, so not a specific value. So I'm just going to solve, find c, and go from there. Got to take the opposite of both sides, though, to get rid of that negative first. We take e to the power of both sides. Since I changed the problem, I'm not sure if it's going to work out nicely, but we'll find out. E to the -x plus -2 over x plus c. You can rewrite that as e to the c. Leave the x's up here, though you don't have to. You can just split all 3 pieces up if you want to. That's fine. But I like c, e to the -x plus -2 over x. I think it will work out fine. Don't forget this 1 minus y. We're going to have to solve for y eventually, but now's a good time to find c. I have the point 1, 2. I think this will work out. So I get -1 when I plug in 2, c e to the -1st plus -2nd. So that's -1 equals c e to the -3rd. C is equal to -1 over e to the -3rd. That's the same as just -e to the +3rd. If you want to do that. Okay, let's move that up here. So I have 1 minus y. Don't forget, I have not solved for y yet. Is equal to -e to the 3rd, e to the -x plus -2 over x. You can combine this power if you want to and have a plus 3. I'm going to subtract 1, divide by negative 1. This will turn into a positive e cubed, e to the negative x plus negative 2 over x plus 1. So subtracting 1, that's a minus 1. Take the opposite of both sides, becomes a positive 1. And this is the answer, okay? Those problems will prepare you for your quiz today. The results on this quiz were not great for my 8A students, so there's like a 15-point curve. Do the quiz before the end of the class period. You have 35 minutes to do it. That's all you have for me today. Make sure you've done the check-in, but I'll be checking in to make sure you do the check-in. Get ready for your test. The test results have not been great. The ones who have really been working hard and continue to work hard and study, they did well. There's 23 questions, but it's tough to finish in the time provided. So, prepare. All right? Don't cheat because that's not helping anybody. Material is going to get harder too. Unit 7, Unit 8, Unit 9. Stuff gets trickier. All right. Good luck out there. Email me with questions.